Hello, this is Brian Gale. I'm one of the quality engineers for the Trimble Business Center team. Back in October, we did a presentation on working with RTK, total station, and leveling data. So this is going to be a re-recording of the morning session. I'll briefly go through a few of the slides just to give a brief background. We had the concepts of global, local, and grid coordinates that we talked about. We also talked on site calibrations and offered some best practices for this. We also, it's not shown in the list, but talked about local site settings and working with OPUS solutions and how to update your project. Okay, so again, the three different types of coordinates that you're able to view in TBC. We have the global, which is associated with the WGS 84 ellipsoid. Then we have a local coordinate, which is also based on that same ellipsoid until you perform a site calibration, and I'll go over that in detail. That's when you'll start seeing differences between global and local. You'd also see differences if you chose a coordinate system that had the definition already defined with a shift, typically with the 7-parameter shift. There's many of those systems throughout the world. I'm not going to go into any detail about those because this is more focused on site calibrations, but I just wanted to make that clear that those would be the couple times that you would see differences between local and global. And we also have grid coordinates, which everyone is familiar with, the northings and the eastings. Those are projected to a grid projection plane, quite similar to any state plane or UTM type of coordinate system. Local site settings. This is the area of TBC where you can move that grid projection plane to your job site, and I'll go through that in detail as well on how to get yourself a ground scale factor that's suitable for the project site that you're working in. Then we have site calibrations that I was mentioning earlier about when you would see the differences between global and local coordinates. Essentially, once you perform a site calibration, you are developing your own coordinate system. So in that instance, you're going to have a shift between your WGS 84 values and the grid points that you're calibrating to, and the magnitude of that shift is directly related to the magnitude of the shift that you would see between your global and local coordinates. Okay, so I will get into the project and demonstrate some of these concepts. Okay, so this is the same data set from the October session. I do have a Google Earth view of this data, and you can see that it's fairly urban type environment. Your basic roadway cross-section type survey, and you can see here that the base point is located in a nice open spot that we all look for, and this particular data set was started with a random control point and using the here function in Trimble Access. So there's some ways to improve that unknown starting position, and for those of you who are not familiar with the RTK and logging style, I'll go through just a quick demonstration on where those settings are. So in Trimble Access, if you go into your settings, survey styles, and pick the style that you use for your setup, you can go to your base options, and there's a survey type box. Now, this is a slick method of also collecting a static file at the same time that you're collecting your RTK information. So if you use the RTK and logging style, at the end of your 8, 10, 12-hour day, you've got this static file that you can upload to any available processing service. Like we have here in the US, we've got the National Geodetic Survey that provides us with the OPUS service. So this method here is the easiest way to improve that starting point of your base. Okay, so let's just take a look at this project, and I'll get out of this. Okay, so right now this is simply 2 job files imported into TBC, and it was site calibrated in the field, and local site settings were also used in the field to perform a ground scale factor. And this type of project is intended to have that ground coordinate type system, meaning if you set a total station on one of these points and shot a horizontal distance to another, you would want your RTK information to match as close as possible to that scenario. So a couple things that you can do is use the inverse command. This is going to be your friend that would give you all this information. What you'd need to do is inverse randomly throughout your site. I usually pick 2 points opposite of each other and pay extreme close attention to the grid distance and the ground distance. And so you can see here in almost 3 miles, we've got just a little over 1/100th of a foot, actually a little bit less than 1/100th of a foot, and 14,000 and some odd feet. So that's pretty good. What that tells me as an office person is that the field surveyor used a fairly decent project height. So let me jump back just briefly to Trimble Access and show you where this project height comes from. So when you create a new job, and again, it's the type of job that's not state plane coordinates or UTM. It's more of your local type of survey. Possibly even an arbitrary 10,000 starting point type project. You have choices here in your coordinate system type, and no projection, no datum will ask you right away what's the project height. So you've got to give this some serious thought. I mean, you can press the here button, and if you have this hooked up to your base, it will automatically populate a snapshot of what your base is reading. Now this works pretty good unless you have your base, let's say 200 feet above your job site on top of a hill, for better radio coverage or just simply convenience. Now in that situation, the project height of the base might not be suitable if the majority of your work is 200 feet below. So you want to keep that in mind, because the higher you are or the lower you are from the majority of your project work, you are going to be introducing some distortion between these inverse measurements of the grid distance and the ground distance. I'll give you just a quick rule of thumb. For about every 30 meters or 100 feet above or below the average of your project, you're going to be introducing about 2.5 hundredths of a foot distortion per mile, or 5 millimeters per kilometer. So keep that in mind when you set up your projects in the field. You need to be somewhat realistic with this project height. Okay, so again, take some time to randomly inverse around your site, checking this relationship between the grid and the ground. So you can see that this data set's pretty good. I mean, there I just clicked between 2 points just under 6,000 feet, and they've got a matching grid and ground distance. Okay, so another thing that you might want to try is going into your reports, and if you select Project Computation Report, This will give you a pretty concise report as to what was done in the field as far as this project height and the ground scale factor that was produced from that, and along with the site calibration adjustments that were made with the data. So here you can see in this report, right here at the top, you've got the local site settings. You've got this project height again that was entered in the field, and the ground scale factor that was produced from that. And if we scroll down, we've got the projection origin, which if you pay close attention here, these are equal at this moment. That's because a no projection, no datum type of survey style doesn't have an origin until you perform a site calibration. And I'll briefly show where these numbers come from. They actually come from the very first point pair that you put in your site calibration list. So if we scroll down, again, we've got some repetition here. We've got the local site settings, the origin, the project height, ground scale factor, and then even further, we've got the translations and rotations of the site calibration that was performed. Okay, so let's actually look at this site calibration that came from the field. So if we go into site calibration, we've got some parameters here. I'll talk about this shortly, but let's look at the point list. Okay, so this surveyor used looks like about 7 different points, and I just want to show these values that we have on this first point pair. Okay, so I'd mentioned the first point pair is what determines the project origin on a no projection, no datum type project. So you can see here this latitude and longitude. It's actually the latitude and longitude of the grid point that you're calibrating to. So I will show that information here by simply coming in and selecting this point pairing 208 to 508. If we look at the point properties of this, you will see this local coordinate. Now again, local and global are different because the site calibration was performed. So this is this latitude and longitude of the local coordinate, you'll see matches this local site project latitude and longitude, and it's also the projection origin as well. So I just wanted to point that out. If anyone's curious where your origins come from on a no projection, no datum, it's the first point pairing. Okay, so let's take a look at the local site settings. And again, this comes directly from Trimble Access in this data set. And if we select the global coordinate type, again, we're going to see this familiar 1155 that was keyed in the field in that project height box, and then the ground scale factor that was computed from that information. Okay, so let's say that that we're not happy with what we're getting from the field and we want to start over. We can uncheck this box and essentially remove this ground scaling that's taken place from the field. I want to show you though a real important feature here, or concept, that the grid coordinates that were either keyed in or imported through a CSV file, these coordinates are going to change once you do this operation. So once again, let's look at 208. If we pay close attention to this northing and easting, once I uncheck this use ground coordinates, everything goes back to 1, and as soon as I hit OK, I'm going to get this box saying that we need to remove the site calibration. So the coordinates now of this point 208, once we hit recompute, and let's look at the coordinates. Actually, since this it's good this happened. Again, this was the origin of your projection, which means that all of your ground scaling originates from this location. So point 208 did not change in northing and easting. However, let me undo this. Let's look at a different point across the site. Let's go down here and find one of these other calibration points. Okay, so 165. Okay, the northing and the easting that we have here. Watch what happens when we go into local site settings and undo the ground scaling. Again, this is a keyed in point or an imported point from a CSV file that was used to calibrate with out in the field. So again, it's going to say remove site calibration. Now, that point number 165 has different coordinates because once you remove the ground scale factor, it's global. It takes widespread effect across the entire project. Now, there is a method of importing points into TBC that will keep these fixed in their original position, but you don't have that option when you simply import job files from the field. Okay, I wanted to emphasize that because local site settings, it it has widespread effects here, and you want to just, if you're going to be modifying what you get from the field, you need to be aware of that. So the next step that you should do is actually get rid of all of those points out of your project and re-import them once you've developed a more refined local site setting, project height, and ground scale factor. Okay, so I happen to know that those grid points that were keyed in from the field happen to be point range of 124 to 208. So I'm going to just select those and delete them. And so our site calibration has been removed and the local site settings has been reset. So let's just take a look at what that means. So if we open the inverse tool and start inversing between points across the site, again paying close attention to the grid distance and the ground distance, you can now see that we have a sizable difference, and that is, if you recall the graphic that I showed where the grid projection was sitting tangent to the ellipsoid, that's the state that our project is in at this point. We no longer have that elevated grid projection that sits at a nice average for our job site. So let's again, this job came in from the field looking pretty good, but we'll pretend that we want to redo all of this. So how would we come up with that average that best fits our project? Well, one of the ways that we can do this is we could simply select all of the points in our project, and we have an average points command in the survey ribbon. And what this does is it takes all of your point selections and comes up with an average position and elevation based on all of those shots. So if I go ahead and execute this, I'll call it just average, And I'll go ahead and compute, and again what this does is, using all the information, gives us this point here that we can take a quick look at. Now you remember the 1155 that was used from the field. Now that we've got all of the data into the office, we can take a more comprehensive look, and it looks like it was pretty close. Again, going back to my plus or minus 30 meters or 100 feet above or below the real average of your project is going to introduce, those distortions that I spoke of. So this right here is showing me, a slightly different number that I might consider using. Now again, you need to be aware of the terrain that you've been surveying. Again, the idea of putting your base high up on a hilltop, which we've all done, might not be a good influence on this number. So you need to just be aware that, this command will come up with an average based on all of the points that you select. Okay, so now we can go back into that local site settings, and by the way, you can leave this at grid or global. It's really your choice. If you wanted to create an origin on your project that's a nice, well-rounded number that you might have to report, on your surveys, you could do this. You would want to keep it, within your project area, because again, that's where the origin is, and that's where all of your ground scaling is going to be calculated from. I'll go ahead and flip this back to global, and again, that 1167 number that we got from our average, we can simply type in and replace that older number. And the origin, again, that's up to the user. I mean, we could leave it out here at 508, or we could simply come in and put it at the base point. Oh, there's one other issue that I want to cover. That's the OPUS solution. So again, going back to the RTCAN logging, if you use that type of setting, you can send that static file out to a publishing or a processing service, and I've got a OPUS solution for this point that we get back from the NGS, and it's got all of our post-processed values. And the slick thing about using the online processing service or the external processing services in TBC is when you get this report, you also get this XML file, and what we can do with that is simply drag and drop into our project. And if we take a look at this, remember, point 50 was established through the here key. So that's a, we all know plus or minus, value based on a snapshot of the readings that were coming in. This is now the OPUS solution. Just out of curiosity, take a quick look at what those differences are. And a little over 6 feet by 1.5 feet vertical. So to get our project base on this new lat long that we got from our OPUS solution, we can simply select both points and use the merge points command. So this merge points command has a couple options in here, and whichever point you want to be the final point, you need to make sure that radio button is appropriately selected. So we want the OPUS solution to be the final position, and this wasn't checked, but if you want to make sure that you check all points that you've selected, and then once you hit apply, boom, now the project is originating from the latitude longitude of the OPUS solution rather than that original here position. Okay, so now that we've introduced a that XML file, that OPUS solution, there is well, a couple things. One, the point name, you can simply select and change it back to 50 for consistency. And the other important thing that we need to do, site calibrations cannot be performed from local coordinates. They have to be global on the base. So if we take a quick look at the point derivation report of point 50, we'll see that the use to calc column, this is an important column to pay attention to. You've got all of these sources of information for this point, but the one that takes hierarchy over everything is going to show this use to calc with the northing, easting, elevation, and elliptical height. So in this instance, because we imported that XML file, we've got this local coordinate that is governing the position of 50. So what we've added into 370 is the ability to select these local coordinates now and right click and we get the context menu. You can change local to global. So I'll go ahead and do this, and you'll notice now that that local coordinate became an office entered coordinate with global quality. So I'll go ahead and just prove this again with the derivation report so that we can see that point 50 now derives from global values instead of local. So that's real important, because you'll get that familiar, your base is not derived from global coordinates if you tried to do the site calibration without choosing this step. Okay, so let's go back to local site settings. I wanted to show how you get that OPUS solution into your project. So we'll go to local site settings again. You can pick any location in your project. This is really up to you. And again, we'll change this to 1167 because that's a better average. And if we select either of those boxes, now we can pick the base point. So now the base point is going to be the origin of the projection and the local site settings based on these values. And if we click the use ground coordinate box along with compute ground scale factor from the project location, which are these numbers, we'll now get a new ground scale factor. So I'm going to go ahead and OK this. And I'm also going to get rid of this average point that we no longer need. Okay, so we've applied a new ground scale factor to our job. Let's again, it's real important, get out your inverse tool and start rechecking again some of these inverse distances. So now we're getting some pretty tight results, even though we had very reasonable results straight from the field. And we're not going to see in that 12-foot change that we've applied, we went from 1155 to 1167. We're not going to see drastic changes in these inverse values, but that's just something to be aware of. You may get some values from the field that are completely not even close. So this is just to show how you can fix and change those types of errors that might happen. Okay, so now we're ready to recalibrate with our site calibration. So again, I removed all of those grid coordinates because of the changing of the ground scale factor. and we saw the effects that that had. So I have a file that contains those same points in a CSV format. So what I'm going to do is import this, and I happen to know that it's point northing easting elevation. We'll go ahead and just make that a control file. And now we have our grid points back into our project. And if we zoom in here, I did put C's in front of the points just so that I could see them a little bit easier in our Project Explorer. They're now all down here at the bottom. So we go back into the site calibration command, and I briefly mentioned earlier that we have some options here, so I'll kind of quickly go through these. The set scale factor to 1. This is a scaling of your observations. It's not a scaling of the projection. So you need to be quite aware of the effect of this. If you leave this unchecked, let's just say for example that you're only going to calibrate between 2 point pairs, and you've got grid points that you've imported that may have some error in them. Let's just say that there's a foot of error. If you leave this box unchecked, TBC, Trimble Access will also do the same thing. There's this option in there as well. It will find a scale factor that all of your observations need to be scaled to in order to fit perfectly between those 2 point pairs. So I just wanted to clarify exactly what this does. I would recommend setting it to 1. That way no additional scaling is performed on your observations, and it's purely going to be how well they fit with the grid coordinates that you've imported into your project. Now the vertical also has a couple options. We've got a vertical shift plus inclined plane, and then we've got just a vertical shift only. It is up to you. However, the inclined plane, you need to be aware that, again, if you only used, say, 2 or 3 points, you could quite easily introduce a tilted plane in your project. So again, it's based on the number of points that you use. 4 or more points is not going to have the drastic effect with this as it would with 2 or 3. So you just need to understand exactly what this option does, and that's the difference between the two, the vertical shift only and the inclined plane. I would select vertical shift only. Then that way you're looking purely at what vertical shift is necessary to fit the number of vertical points that you've selected in your project, and less with this you have less of a concern with geometry surrounding your site. Let's say that all of your vertical points were running down this road and you didn't have any up in this region. It's kind of like calibrating on a knife edge there. You've got a lot of wiggle room that might show drastic effect up in this area if you were to use the vertical shift and inclined plane. So I'm going to go ahead and go into the point list, and I won't bore everybody with trying to pair up every single point pair that's in the project, but I'll go through a few here, and you'll notice that when I select these points, if TBC recognizes that the grid point also has elevations. Let's just look at this last one that I picked. So this imported grid point has northings, eastings, and an elevation. If it were missing the elevation, then this would automatically only pick horizontal only. And the same goes for vertical points. You may have some points in your file that don't have any position, but you have a known elevation. They're not going to be shown in the plan view, but you can simply pick them. They would be shown in the Project Explorer. Let's say you had BM1 and BM2. You could select the appropriate point and just simply key in those point values, or those point names rather, and it would match with a vertical only on this. So I'll pick a few more and we'll run through the site calibration. And yeah, again, there's probably a dozen or so points in this project, but I'll only pick a few. So let's go ahead and compute, and you can see here that the horizontal residuals, we have about 7/100ths, and the vertical residual 3 3.5 At this point, you could, take some time and really go through the list and find those points that have higher residual. And for example, this 443, what we can do is go back to the point list and say, well, I liked the vertical on that, but I didn't really like the horizontal residual. So you can switch that to vertical only, recompute, and now our residuals dropped almost in half. We're down to a little over 4.5 or over 400ths, and the vertical residual still remained the same because we didn't make any changes in the vertical. So this is kind of the fun part, going through and picking and throwing out points that don't fit quite as well. And then once you've got this to your satisfaction, let's say that you might have some future work that's coming up that will be even within this area or close by. You've got the option now that you can save this as a site. So let's just do this, and we'll just call it road project 1. Okay, so that's saved. What's saved with that is everything about this project: the origin, the ground scale factor, the site calibration, and all of that goes to your coordinate system manager. And there's a folder called local sites. So if you open that local sites, you can see these various projects that you may have saved in the past using this method. And these are always available when you create a new project in TBC. I'll show that at the very end, how if you wanted to start a new project, you could say, oh, I want that road project number 1, so you can have access to that and use all of the parameters that you've gone through, and that'll be available for your next project. Okay, so once we're satisfied with the site calibration, we can go ahead and OK that, and now we have our project has a new ground scale factor and a new site calibration. So the next thing that we've got for this is we've got some leveling data, and this leveling data happens to be in a StarNet format. And if you have that type of leveling data, or even let's say you've done all your level work in a field book, you could simply come into the leveling editor and manually key in all of that information, and all of this will go directly into your project. But I'm going to drag a StarNet file, as I mentioned, and we now have the StarNet import filters in TBC that will recognize this format, and once you import, it will populate that in the level editor. And this is where you can go in and QA your data. One thing I want to note is that any points that do not exist in your project, let's say all these turning points for example, if you leave the create checkbox checked on those, TBC will not know how to form the lines between 507 and 84 in this example. It does not know where TP1, TP2, or TP3 are, so if you simply uncheck these, it's not having any effect on the leveled information. This is purely for the graphical purposes that you'll see here in just a second. So I think there's one more, this guy, TP25. So everything else in the leveling file, all these leveled observations went through known points. Here's another one. Went through known points in the project. So that's one thing to be aware of on this create column with check marks. So I'll go ahead and OK this. And so right away you start seeing these purple level lines running through the project that show the route of the leveling that was performed. You can see it's coming through here. We've got some flags that just popped up. So, you know, some of these RTK observations may not fit quite as well as your leveling. We've all run into that. Let's just check out this guy. So, in fact, here's a great example. This shows that the northing, easting, and elliptical height that's being used to calc for 0.58 is derived from the RTK observations. However, this new leveling information that we just imported is taking higher precedence over the elevation of the point. And you can see that again in the used to calc column with the E notation. That being said, the elevation from the RTK vector is differing on this point by almost 2/10 of a foot. So we've got a little bit of multipath, or perhaps just a bad shot on this point. Okay, so that's just to show how leveling data affects the project. It does have the smarts built in to recognize that hey, leveling is more precise method of determining elevation than RTK vectors. So, and once again, I just pulled up a different point just to illustrate that. Okay, so we'll move on now to total station data. So that's how you get your leveling information in. And again, I could have manually keyed in all of this through the leveling editor. So that's what our leveling editor is for. Okay, so total station, I've got a file here. It's a job file with several cross-section shots, and it utilizes the same control points. So this scenario here where you might go out, say for the first couple days, collecting RTK information, maybe followed up with leveling, and once you've got all that control work done, then that's where you would upload to Trimble Access and go out and commence your cross-sectioning and other total station work that you might be needing for the project. Okay, so once this is imported, let's take a look at some of these setups, and just zoom in here and try to pick 0.78 just randomly. Let's take a brief look at the point derivation report. You're going to see me open point derivation report a lot, and it's something that's a pretty important area that you need to keep eyes on, and this is why. You'll notice that once I imported my total station data, that contained either keyed in positions for these setup points, or perhaps uploaded data from TBC, like I had previously mentioned. When that data comes back into TBC, grid points have a hierarchy that will override observations, and that was covered in a Power Hour, I believe in February or March, in quite detail, discussing the different hierarchies of these grid points. So that's what's happened here, and what that means is all of this observation information is being essentially ignored or not used to determine the northing, easting, and elevation of this point number 78. And you can see that again by this used to calc column. It is using the northing, easting, and elevation of this grid point. The elliptical height is being used from the RTK vector. So we may not want this. We may have older grid coordinates. Let's say in the office, like I had just shown, the site calibration and the ground scale factors may have been changed to a better value or a better fitting value. So when this happens, just need to be aware that what comes in the next day and after, you're going to have these grid coordinates to contend with. And again, the point derivation report clearly shows this. So let's see how we address this. The easiest way to address it is to go to your Selection Explorer. So the Selection Explorer will show all of the data files that you've imported into your project, and this total station data happens to be this RD topo that I just imported. So once you select that, let me zoom out here and show everything associated with that job file is highlighted. So all of these setups, all of this topo information, and any points that were used for backsites and so forth, they're all going to be highlighted in this file. Now any grid coordinates, again, the grid coordinate will override. All of those will be shown in this selection area as well, and they're conveniently grouped together, as you can see right here at the top. So what I would do is hold down Shift, select all of these points, and open up the properties. So when you've got the properties pane open, you've got all these varies in here because you have multiple points selected, but the important thing is the status. If we select this, we can disable all of these observations, or not the observations, but all of these grid coordinates. Okay, so now that all those grid coordinates are disabled, we'll want to recompute with F4. And once this is crunched through, let's go back to that point 78 again. So I'm going to select 78, and once again, point derivation report. Now you see the difference. I wanted all of the northings and the eastings and the elliptical heights to be based on the RTK observations. I wanted the leveling information to still be based on the, the elevation to be based solely on the leveling information. You can see once again that in the used to calc column we've got this, all this information is provided to us, so we can just quickly look and say, okay, great, we're back to RTK governing the position, and the leveling is what's governing the elevation. Okay, so that is it. I've shown how to change your ground scale factor through local site settings, recalibrate your project, importing leveling information, and and also importing your total station data and the management of these grid coordinates. This is key, because if you do not manage these grid coordinates, the effect of any adjustments, and that's another issue as well. I didn't go through network adjustment on this project. That's actually being covered in this month, in May. We have a extensive power hour on network adjustments. So anything like that, new site calibrations, new local site settings, network adjustments, any of that, when you bring in your total station data with all of these grid coordinates, you need to manage these like I had just shown, or else these are going to override any form of adjustment or any other value that's on these points. Okay, so that concludes showing how to work with the RTK total station and leveling data. I did say that I wanted to show how you could use your save as sites. So let's quickly, we're going to create a new job, and once your new job, your blank project is in view, you can go into project settings. There's a couple ways to go into project settings. You can right click on the name of your project. Of course, it's all unnamed when you start new. Or you could also find project settings up here in the quick access bar. So either one take you to the same place. You're going to want to pick the coordinate system folder and select change. Now you've got a calibrated site radio button that if you select, again, this populates with all of those saved sites from site calibrations in the past. They'll all be in this same location here, so you might want to give them meaningful names. But again, if I had a second project come up a month or two later that's within that same project area, and I was very satisfied with all the control work that I did, and didn't want to repeat all of that, I could simply select it, click finish. Everything about that job, as I said earlier, is now populated automatically into the coordinate system settings. You've got the local site with that 1167, the same origin, same ground scale factor, projection settings, and so forth. So this is a slick way to stay consistent with neighboring projects. Okay, so that's it. And any questions, my email was on the first slide. Feel free to send me an email if you have questions. Thank you.